and welcome to the world of radioactive tracer surveys. Renegade is passionate about injection profiles and tracer logs. We have a wealth of knowledge and industry experience regarding downhole tools, processes, and data interpretation. Injection profiles serve our customers in a variety of ways. The most common is to evaluate CO2 or water injection flood performance to determine injection distribution as it leaves the well. We analyze any out-of-zone injection, channeling or behind-pipe fluid movement, and cross-flowing zones that are communicating. The scope goes way beyond increasing oil production as we run many surveys in lieu of state or federal laws to verify conformance to environmental requirements with injection and disposal wells. We also use this process as a way to locate tubing and casing leaks in a variety of scenarios. Let's dive deep into a well and learn about the tools and the processes that Renegade uses to gather valuable data used to build an injection profile log. Working from top to bottom, we have a cable head rope socket and then a tungsten weight bar. Next, with the logging tools, we have our ejector tool, casing collar locator, gamma ray detector, 3-arm caliper, and temperature tool. As we begin to log a well, we have steady injection, and we start with the injecting temperature survey logging down. Temperature surveys are vital to the log interpretation as we study how fluid movement and losses affect the gradient changes. On water wells, the injecting temperature heats up as we lose cooler injection water. As we log below bottom of injection, the curve should make its way toward natural ambient well temperature. This becomes the first visual of where fluid is going and can give the first indication of any problem areas. We tag bottom of the well and open our 3-arm caliper and log up the well. This gives us an average hole size that we use when calculating fluid velocity. It is here that we find scale buildup or areas of bad casing. Next, we drop down to bottom again and pull a base gamma ray and CCL log. This ensures that the profile is correlated and on depth. This also lets us know if there are any areas in the well that have high levels of natural radiation. Now we start the fun part of the log, with what we call the tracer. The ejector is loaded with medical-grade radioactive iodine that has a short half-life decay time. The tool works as a downhole syringe, and once some of the RA leaves the tool, it becomes soluble with the well fluid and begins to flow down with injection. The logger makes multiple drag runs through this slug of material, measuring the radioactive counts with the same gamma ray detector used to run the base pass. The field engineer first takes a measurement of the slug's intensity. If half of the slug size is gone, then half of injection is gone. We also make a velocity calculation at each pass by taking the distance traveled, multiplied by the hole size factor, and then divided by the time that it took to move that given distance. All of this goes into generating a profile of how much fluid is leaving the wellbore in each zone. When looking for a single hole in the casing, this data can determine where collar leaks or bursted pipe is located. We always prefer to use radioactive tracer tools instead of spinner tools for several reasons, but the most important is we can see fluid movement behind pipe. When all of this material has gone into formation, we check for fluid channeling down by ejecting RA into an interval where fluid is known to be moving inside pipe. We drop our tools down below and wait for radioactive counts to increase, which indicates fluid moving down behind pipe. We then shoot stationary velocity shots every 10 foot through zones of fluid losses to break down the losses into smaller intervals. We keep the tools still this time and fire a small slug and time how long it took to go from our ejector port to the detector. We then check for upward channeling fluid. We watch RA material flow past our detector, go out the perforation, and move up behind pipe. We can chase this fluid up the annulus until it goes away into formation with our tools still inside pipe. Upward channels are so important to find because this fluid movement can pressure up zones unintentionally, as well as cause casing damage that can lead to casing collapse on top of the packer. Once we check the packer for leaks, verify injection rate in the tubing, and perform any repeat surveys, we shut the well in for 1 hour. We then run a 1-hour shut-in temperature. This survey shows us areas of fluid storage and communication, and it will back up the claims made on injection. The injecting and shut-in temperatures should come together and read the exact same below bottom of injection, whether that happens inside or outside pipe. The last survey is the crossflow checks. RA material is released throughout the wellbore and then drugged through to check for movement. When we look at crossflow movement, we can tell which zones are high or low pressure by annotating fluid crossflow velocity and directional movement. Once you put all the pieces together, you have a picture of what your well is doing. Remember, if you don't run these logs, you just have to assume that injection is going wherever you created the conduit for it to go. Time and time again, we find this is the wrong assumption, and money is being pumped away in the wrong place. Don't just guess. Give us a call so we can help you increase flood performance, renew your permits, or find your damaged pipe. See you in the field.